You've been wondering why some people do math so easily? Like, they just think of it and now they got up to an incredible solution? Well, I'm gonna say to you that math is not really easy, but there are some ways on how you can understand it clearly and how you can probably solve most of the problems. So this night, it's 12 in the midnight. I'm gonna share to you some tips on how you can actually improve your understanding of math and how do you actually love it. Bear with me in some disclaimer. I'm not going to tell you that the math, like all of the math will become easy, but I'm gonna share with you how math people think and how how they actually what are the techniques that they use in order to understand most of the problems. And once you understand the problem, it becomes much easier to actually solve the problem. So the number one step in solving the problem, it's actually you have to understand the problem. You cannot attack something that you don't know. During our elementary days, I remember when I was a child, the teacher always asked the class the 5 steps of understanding the problem. It's what's the given, what's the asked, what's the question requiring you to do, and the formula and the solution. But it comes down to, once we get to the higher level, it comes down to understanding the problem itself, how the problem was constructed and how it works. So before you start answering a problem, make sure you understand the problem itself. What are some errors that I commonly see in students trying to solve math problems is that they actually go into the solution first without actually having to understand the problem. And for me that's not a good way of actually solving it, unless even most of the good people in math, they actually understood the problem really well. That's why they can easily come up with a solution. But it's very logical. Wrong understanding of the problem leads to wrong solution. And the second tip that I'm going to show you guys is having to know beyond the formula. Formulas are mathematicians' way of expressing some idea or some relationship. It may be in the form of an equation or some expression, but behind those numbers, there has to be some huge meaning unto it. It's not enough to actually memorize the equations, but we have to also make sure that we understand how these equations came from. So most of the time when I encounter some equation that's really difficult, or I encounter some equation, I actually search on Google or YouTube how to derive that equation. In that way, I can understand how these equations were formed. In a similar manner, I get to understand the concept behind it. And the more I understand the concept behind it, the more problems I can actually solve using that problem. And what's better, like one of the advantages of having to know the concept behind an equation is when you forget the equation, you can actually derive the formula for it on the spot. Sometimes there might be so lots of equations that we have to memorize, and we forgot most of them. So what you can do is know the concept and try to derive it on your own in order to have an actual solution. Sometimes it takes time. It takes time to derive something, but this is the relation to the third point. And the third point is actually to practice a lot. The great philosophers, mathematicians, and math Olympiads, when you ask them their key technique in order to being good in math, is they just keep on practicing. It's never wrong to practice. It's never wrong to repeat the same things over and over again until you become fast at it. And I ask you, 9 times 9, most of you or all of you would actually have an answer immediately. It's 81. But why? Because when you were a child, you keep on repeating 9 times 9 over and over again, until it actually pops up your mind that 9 times 9 equals 81. Same thing to most of the problems. If we like have a square root of 144 and we know that it's equal to 12, see that by repeating those patterns, those same steps over and over again, you become faster at it, you become more efficient at it. That's it. Practice, practice, practice. But there's one key thing that I have to emphasize. It's not enough to practice, but the thing that we need to do is correct practice. So practice is not enough. Correct practice is much better, and it's the best way. Even though you practice and you practice and you practice, and what you practice is actually wrong, it's not actually efficient, then the results are not good. But if you practice correctly, you have the right routine, then the results will be much more promising. Now we have come to the last tip that I'm going to share to you guys. It's thinking outside of the box. I mentioned it a lot of times in my videos, because thinking outside of the box is what makes you above the situation. So imagine you're in a flat plane. I kept on like mentioning this example. If you're in a flat plane and you want to know how that flat plane works, you have to step out, you have to step up, look at it from the top view in order to see everything clearly. It's like a frog floating on top of a river. The frog does not know that there's something under him and there's something above him. The only thing that the frog can do is to actually move out of the water, and then the frog will realize that, oh, I'm just floating in the water, there's something beneath me, and there's some air above me, there are birds flying in the clouds. Thinking outside of the box does. It's like the same way in imagination, but this time it's much more critical. Well, I can say that imagination is a crucial part of thinking outside of the box, but the critical thinking part, it's one that's the most difficult above all. Led most of the scientists in their discoveries, in their amazing discoveries. Like, for example, Albert Einstein. Like, who the hell would have thought that the space and time are something which are not fixed but relative? Like, how on earth would someone realize that there's some fabric of space-time which we all live in, and gravity is just the bending of this space-time? If Albert Einstein wouldn't think outside of the box, probably he wouldn't got into it. In the end, in our daily routine, I want you guys to incorporate all those tips, even in the simple things. Like, for example, you see some car moving on the street. You have to ask yourself, why is the car moving? What's the reason? What's the physics behind all of this? It will be nonsense, but it will train your mind to actually think critically, to think outside of the box. And you have to ask yourself also, is the current design of the car efficient, or is it the best design for the car? Most of the daily objects, you have to ask, is this the best version of the object? What can I do to make this better? These simple things, it will train your mind to become more critical, and then when you encounter some math problems, it becomes much easier to do. But I do not tell you that this is the guaranteed way, but I'm just sharing with you the tips that I learned over the past years, and what I learned from the math courses that I took. And hopefully, guys, by the end of this video, you have to be critical as well. You have to be critical into everything that I say. You don't just believe everything that I say. You have to figure this out yourself, because every individual is different. What applies to me may not apply to you guys, and what applies to you guys may not apply to me. And also, if you have some tips or other examples that you might want to share, feel free to comment down below. And be sure to subscribe, because I post videos every day, irregardless of the time, irregardless of how busy I am. So that's how important you guys to me. So be sure to hit the subscribe button and turn on your notification bell in order not to miss out in the videos. I will see you soon, guys, in the next video. It will be tomorrow. Good night, everyone. It's time to sleep.